Today, on how it's made. Pocket knives. Making them is an exercise in utility. Soapstone products. We go underground to dig up the details. Electric pole transformers. The shocking truth. And traditional snowshoes. The production process, step by step. Pocket knives can be used to cut rope or slice an orange. Unfold one of the blades and there won't be a dull moment. Folding knives actually date back to ancient Rome. Many centuries later, the smaller pocket-sized versions came along, allowing people to carry around knives without wrecking their pockets. They pack a lot into a pocket knife. It can contain several blades and tools, all of which can be retracted into the handle. To make pocket knives, rollers feed a strip of stainless steel to a series of dies. Like powerful cookie cutters, the dies punch out blade shapes. They cut holes for installing them in the handle, stamp the company logo, and form grooves with which the user can grip the blades. A trip into a fiery furnace hardens the metal. It's the first step in heat treating the blades. Once they're cool, an operator places blade shapes on the magnetized rim of a rotating carousel. It moves the base of the blades under an induction heating coil. The heat anneals that end, making it pliable enough to bend and easier to fit in the pocket knife handle. A robot now transfers a blade shape into a computerized grinder that bevels the edge but leaves it blunt. Honing will give it a cutting edge later. Here you can see the difference the grinding makes. Vibrating ceramic pellets polish the blades with paste for 32 hours to achieve a mirror finish. A magnetic belt collects them and transfers them to the next station. Meanwhile, a rocking cutting tool carves ridges into a piece of cow shin bone. The shin bone will adorn the pocket knife handle. They submerge a bag of those ridged shin bones in a vat of dye, tinting them a vibrant green. Cow shin bone is just one of many materials used to make pocket knives look attractive. Some are synthetic, and some are natural. Like this material, it's actual mammoth ivory they're riveting to the pocket knife hilt. They apply an epoxy adhesive to decorate these pieces of bone with metal inlay that's embellished with flourishes and lettering. They trim the excess bone so that it's flush to the metal liner. Next, they place a spring on the underside of the bone and brass part, followed by a rocker arm and a spacer. They finish off this sandwich with another bone-covered brass liner. They insert blades in one end, dipping each one in oil to lubricate it. A pin holds it all together. They pop different blades in the other end of the pocket knife and drive a pin into that stack. A pneumatic tool flattens the ends of the pins, essentially riveting all the parts together. Sometimes they pound a shim between the layers to open them up so the knives can move more freely. It's a little fine-tuning. They grind down the pin heads to blend them to the rest of the pocket knife. Sparks fly as they hone the beveled edges against a belt sander until they're sharp enough to cut. After sharpening, they retract all the blades and buff the knife until it shines. Here, a laser etches an insignia into the bone handle. They enhance the engraving with paint. And now, you have a pocket knife that really makes a statement. Dig deep into the history of civilization, and you'll find soapstone. Over the centuries, it's been used to make everything from cookware to countertops to the kitchen sink. Soapstone doesn't stain or burn, and that's why today it continues to be a rock-solid choice. Production gets off to a drilling start as they bore several deep holes into a soapstone hillside. The horizontal and vertical holes form an intersecting lattice. They loop one end of a long diamond-encrusted cable and attach it to a rod. This makes it easy to maneuver as they snake the cable through one of the vertical holes. They attach a coiled snare to the cable's other end and insert it into one of the horizontal holes, jiggling it around until the snare snags the loop. Once it does, they thread the cable through the rock. They disconnect the snare and untie the loop. Then they crimp the two ends of the cable together, creating one big circle over 60 meters in circumference, which now runs through the rock. They wind a section of the diamond cable around mechanical wheels. The machine moves backward as the wheels turn the cable through the rock. This action causes the diamond cable to saw through the soapstone. The process kicks up a lot of talc dust, the mineral that gives this stone its soapy texture, so they spray water into the cut to minimize the dusty fallout. As the cable exits the rock, it snaps back, so they make sure no one is nearby. It has taken about 20 minutes to slice through this soapstone hillside. Removing the heavy rock will require an excavator. As it pulls the soapstone away from the hillside, it breaks into chunks, each one about 2 or 3 square meters. They wash them. Then a front-end loader forks up each block and delivers it to a bandsaw. Like the cable, the saw has a diamond edge, so it easily cuts through the stone. They get several 3-centimeter thick slabs from each block, perfect for a countertop. They build apron sinks from the smaller end slabs. This type of sink was first popular a century and a half ago. But these days, computerized blades and lasers make the job of building it a whole lot easier. The laser lines serve as guides while the blade cuts the soapstone to precise dimensions. This piece will be the bottom of the sink. They use this precision grinder to taper the sink bottom from the center out so that liquid will flow down into a drain in the middle. They change the tooling and punch out a drain hole in the center. A constant flow of water keeps the cutter cool and the dust down. They mix epoxy resin with hardener to prepare a high-strength waterproof adhesive. They apply it along the edge of the sink bottom, working fast so it doesn't dry. Then they press a sink wall onto the glued surface. They piece together the rest of the sink, and it's ready to blend in with the soapstone countertop. From the shower floor to the stove surround, soapstone can perform many functions with style. Electric transformers. We see them everywhere, yet often take for granted the big part they play in our everyday lives. Without them, raw electrical power would be virtually useless to the average person. Their job is to transform the high voltage from electrical power lines to the lower voltage that's suitable for home use. Transformers lower power line voltage levels to ensure that your appliances don't receive too much electricity. To make a transformer, they start with two materials: paper that's coated with epoxy glue, they tape it to a wooden block, and a 3 mm thick aluminum strip, metal that withstands the heat a high voltage current produces. They secure both materials to the block and rotate it, wrapping the insulating paper and aluminum together. An aluminum bus bar, called the low voltage lead, sends low voltage current out from the transformer. They fold the lead and move the unit to another rotating block for more wrapping. The insulating paper has epoxy glue on both sides. This glue will later melt and bond several components in place. On the next block, a worker tapes on more epoxy paper, then epoxy-coated copper wire. He rolls on a layer of wire covering the paper, then repeats the same process, forming a second layer of copper wire. Now he solders a high-voltage lead wire to the copper wire, then rolls yet another layer of copper wire. He attaches what's called the lead wire out, the wire that'll protrude from the transformer's cylinder, and vinyl-coated wires that'll connect to different voltages out of the transformer. The component they just built is called the coil. Now, using electrical steel, they build the transformer's other main component, called the core. A worker secures the coil and cores tightly together with metal strapping, which will help to fix the assembly in the tank. Then sends them to an oven, where they bake for 8 hours at 135 degrees Celsius. The heat removes any traces of humidity to improve the insulation. The epoxy glue has fused the paper, the aluminum strip, and the copper wires. The assembly goes into a steel tank. They hammer on a rubber gasket around the perimeter and bolt on a grounding wire. Then they insert 3 thermoplastic bushings. They connect the low voltage leads to the thermoplastic bushings, then bolt the bushings to the tank. They adhere an oil filling guide to the side of the tank, then position an automated filling machine. A machine fills the tank with mineral oil, drawing a vacuum to make sure the oil disperses throughout the coil and cores. The oil is used for its thermal and insulating properties. An internal fault detector will alert maintenance crews if there's a short circuit. He runs lead wire through the thermoplastic bushing and secures it in place. Next comes the high voltage connector. Then he bolts the tank cover shut. The transformation, so to speak, is finished. Before transformers go into service, they have to undergo some truly electrifying tests. To test the transformer for field use, this equipment simulates a 145,000-volt lightning strike. Then it's into a water tank to test the transformer for leaks. If it passes, it will appear soon on a pole near you. Historians believe the ancestors of North American native peoples brought snowshoes with them when they migrated from Central Asia some 4,000 years ago. Today, the tradition of snowshoe making lives on, thanks to skilled artisans who make them much the same way their ancestors did, with a few modern improvements. Every snowshoe frame comes from a single piece of hard wood, usually white ash. The craftsmen start with a 2-meter strip about 20 millimeters thick. Using a planer, they thin the middle down to about 12 millimeters. Then it's onto a table saw where they taper each end to a fine point. They take the trimmed pieces, known as bows, and hammer steel braces onto each one. These support the wood where it's thinnest, so it won't break later on during the bending process. They put the bows in a steam chamber to soften the wood. "30 minutes later, they're damp enough to bend without breaking. They start working from the middle, the area called the foe, where the wood is thinnest and easiest to bend. They wrap it around a steel form on a bending jig. Then lay one tapered end over the other and tack them together. Now back to the steamer for a second bow to complete the pair. A temporary crossbar over the width of the frame holds the shape. They use different steel forms to shape different snowshoe models. They set the frame on a bending machine called a press brake, then position a wooden bar on the frame to act as a fulcrum. As the press comes down, it curves the tip of the frame about 7 centimeters upward. They insert a crossbar lengthwise to hold the bend in place. The frames are still damp from the steam chamber, so they need to dry out for several days. Only then can the temporary crossbars safely come out. The craftsmen then sand the wood to a smooth finish. They drill slots on the inside for the 2 permanent crossbars, while another machine stamps those bars with the company logo. It takes just a quick stretch to insert the bars, one near the toe, the other near the heel. Now the frames go for a dip in a vat of oil-based varnish to seal and waterproof the wood. Once the varnish dries, the frames are ready for lacing. In keeping with tradition, the laces are animal hide. Wetting it makes it easier to cut into long, thin strips. A skilled weaver threads her needle, then begins by hooking the rawhide lace through a nylon thread that runs along the inside perimeter. She nimbly builds up a pattern of webbing that always begins and ends with a series of triangular shapes. This intricate weaving technique is a traditional skill passed down through generations of First Nations women. She finishes by wrapping up the heel end of the frame with rawhide, then pulling it tight. Now that the toe piece is finished, she starts weaving the middle piece. Using a larger width of rawhide, she builds up another web of triangles. this time knotting the strips directly onto the frame. Finally, she weaves an opening to leave room for the bindings that hold the snowshoe to your boot. Once the rawhide dries, the webbing will lie taut across the frame. The last step, another coat of varnish to seal and protect both the wood and webbing. And now these traditional snowshoes are ready to make some tracks.